Using the cosine rule to find angles. So you already know that to find the side length, we use this formula here. However, if you're finding an angle, we use the same formula, but a variation of it. Now the first thing I'm going to show you is how to get from this point to this point, because this is really important, particularly if you've not been given this version in the exam. So starting here, we want to get cos A on the side on its own. Now currently, it's in a form where the whole term is a negative, and we want this to be positive. So we're going to actually add all this to both sides. So to begin with, we'll have a squared plus 2bc cos A equals b squared plus c squared. Next, we want to get rid of this a squared from this side, so we'll take away a from both sides. So we'll have 2bc cos A equals b squared plus c squared minus a squared. Almost there now. We've got cos A here, but it's also being multiplied by this 2bc. So we're going to divide both sides by 2bc. So it will become cos A equals b squared plus c squared minus a squared all over 2bc. And at this point, you can now see we've got this formula here. So it's the same formula, it's just been rearranged to use for a different circumstance. Let's apply this to a question. We want to find the size of angle CAB to one decimal place. So we've got CAB, so it's going to be this angle here. So I'm going to label it theta. I'm going to use this formula here, I'm actually going to bring it over, so we've got it written down and we can use it. We'll next substitute in the values, so we've got cos of the angle theta equals b squared, which is 7 squared, plus c squared, which is 11 squared, minus a squared, which is 13 squared, all over 2 times b, which is 7, times c, which is 11. Then you can either calculate this first or leave it in that form. I'm going to calculate it on this occasion. So once you've put it in the calculator, we'll end up with cos of the angle equals 1 over 154, or 0.0064935, etc. Finally, we need theta on a side on its own, so we apply the inverse of cos to both sides. So we'll end up with theta equals cos minus 1 of 1 over 154. Input that into your calculator now, and you'll end up with theta equals 89.62794,687, or to one decimal place, 89.6 degrees. This next question, we want to find the angle theta again. So we've got angle theta here, but it's not angle A, it's actually angle C. Because we want the angle C, so it's going to become cos C equals, I'm going to keep it as b squared, but we don't have c squared, we've replaced it with a squared, so a and c in essence have swapped over. Minus c squared, all over 2ba. So now we've updated the formula, we can substitute the values in. So we've got cos of the angle theta equals b squared, which is 10.7 squared, plus a squared, which is 8.4 squared, minus c squared, which is 5.1 squared, all over 2 times b, which is 10.7, times a, which is 8.4. We'll have cos of the angle equals, we'll type this bit into our calculator, which will give us 0.8847352025. You may want to just round it to 4 or 5 decimal places. And then finally, we want to find theta on a side on its own. So we apply cos minus 1 to both sides. So we'll be left with theta equals cos to the minus 1 of 0.8847352025, which means theta will finally equal 27.78104717, or to one decimal place, 27.8 degrees. And that's it. Here's 3 questions for you to have a go with now. I've left the cosine rule in the bottom left hand corner for you. Leave your answers to 2 decimal places. Pause the video and resume when you're ready for the answers. Okay, the blue question, we want to find angle A. So let's bring that over here. Substitute the values. So we've got cos theta equals b squared, which is 8 squared, plus c squared, which is 5 squared, minus a squared, which is 9 squared, all over 2 times b, which is 8, times c, which is 5. Cos theta will then equal a really nice number, which is 0.1. Theta then equals cos minus 1 of 0.1. So theta will equal 84.2608. Therefore, theta is 84.26 degrees. Pin question is the same, but we just got to be careful with our formula. So I'm going to rewrite it. So we've got cos of the angle B equals, so I'm swapping A with B, so we've got A squared plus C squared minus B squared all over 2AC. Substituting the values, cos of the angle B, which is theta, equals A squared, which is 5 squared, plus C squared, which is 16 squared, minus B squared, which is 18 squared, all over 2 times A, which is 5, times C, which is 16. Cos of the angle then equals minus 0.26875. Theta equals cos to the minus 1 of minus 0.26875. So therefore, theta equals 105.59 degrees to 2 decimal places. Finally, the green question, it says find angle BCA. So we've got angle BCA, so that must make it this angle here. So I'll draw that on the triangle and call it theta. Write out the adaptation of our formula. So we're looking for cos of the angle C. I'm going to swap out A for C. So it equals B squared plus A squared minus C squared all over 2 times B times A. Substituting the values, we've got cos theta equals B squared, which is 38.1 squared, plus A squared, which is 14.2 squared, minus C squared, which is 24.7 squared, all over 2 times B, 38.1, times A, which is 14.2. Pop that in your calculator, and you'll end up with cos theta equals 0.9640678718. Apply cos minus 1 to both sides. So theta equals cos to the minus 1 of 0.9640678718. So then theta will equal 15.41 degrees to 2 decimal places. That's all for this video, and the next video is how to know whether to use the sine or cosine rule. Like this video, subscribe to my channel, stay safe and healthy out there, and I'll see you in the next video.